Good morning, myself Mohd Nawaz. In this today's lecture, we are going to see our Unit 3 SQL queries, constraints and trigger topic, that is active databases. Okay. The last class we have completed the topic triggers, right? In the triggers only one statement we have seen here. In the databases, if we are having some set of triggers, those databases are going to be called as an active database, right? Yes, it is true. Okay, we are defining some set of rules implicitly in the database. Then those database is going to call as an active database. Okay, before going to active databases, let us see what about our traditional database. What was the drawbacks that make to active database to come into existence? Okay, we'll see that. So first we'll see about our traditional databases that we call as conventional databases. So in traditional database, that is Dbms, commands are going to be executed by the database and as and when the requested by user of our application program. So normal in every database and Dbms, what we'll see is whenever the user gives a command, the Dbms is going to execute those commands, right? So same way traditional database also use the same thing. It has a passive update principle, that is client controls the Dbms updates. Means in the traditional Dbms, implicit functions were not there. Like some rules, whatever the rules are there, that has one not defined implicitly in the within the database. Some other clients has going to be control those kinds of codes which is not inside the Dbms but outside somewhere else. So this was that in the traditional databases. However, some situation cannot be effectively modeled by this pattern. Means by using this same situation, we can't execute all of the current applications which require an implicit function. That means automatic rules and set has to be updated, right? So those functions was not done in our traditional databases. So our traditional database model can be look like this. One of the example has been shown on your screen, where it is of ordering. Okay, we are having ordering data here. So these are the external clients which are maintaining those set of rules. Means here T1 transaction is going to be happen, means some user is giving some transaction, like it's asking for 20 copies. How many copies has been sold is keeping that record there, and this stock, some other client is storing these details of the stock, means how many stocks has been left, and order, who is ordering, those are the users. So here the external clients are going to maintain those data. So we are not having the set of rules inside the DBMs to maintain our records. So obviously records are going to be maintained for each and everything, right? For this business also, the records are maintained here, all the solds and the stocks. But automatic rules means if some stock is already less here, right? So what the action need to be taken is not at all described here in the traditional database. So what are the problems we are facing with the traditional database? Let us see with some example. Consider a railway database is there. Okay, so it is a huge database which is having a records for about the information of the trains, timetables, and the seats availability, fares, and so on. Right? We'll keep those records in the railway database. Right? So consider any circumstances in which if there is an holidays or some cultural events, we get more holidays, right? So if we want to book a ticket there, that will be a ethic solution, right? So for that, it has to be a solution. So it may be beneficial to add some additional coaches before that, right? So how we'll get to know public holidays more the customers or consumers are going to book the tickets if we are going to set some rules before only, right? So those rules has gone not defined in the traditional database. Why? This is about seat booking, timetables maintaining, and scheduling of the trains was maintained separately at that time. Okay. However, to administer this situation in passive database is a challenge here. So two possible cases are there in traditional only. What is that? Okay, add additional monitoring functionality for all the booking preceding situation is checked each time a seat is sold. Means we are arranging one client there which is tracking all the details and maintaining whatever the booking time is there is making is maintaining in one data, and for however whatever the seat availability is maintaining there. But however this approach leads to some semantics that is not meaningful monitoring the tag. Why? Because it has been distributed. Again, if some connection failures will be there, it's not going to be work, right? So this is also going to be failure. Second approach. What is the second approach? A polling mechanism. What do you mean by polling mechanism? Okay. Okay. So it's the process where a controlling device waits for external device. Means as we have uh, this define this in the several aspects, right? Means we have divided these things. Means one client is maintaining the schedule, one maintaining the seat availability. So polling mechanism, what it do? It's going to distribute that. So periodically checks the number of seats available. The difficulty in this approach is how means based on the polling frequency. Means if one is storing the details of the all the tickets booked, right, and one is storing the all the tickets availability. But if a threshold value is fixed, means as many users are booking the ticket, number has been raised too much too high. Okay, but fewer seats available. Then that time also to whom to give that first come first serve, that has not been decided at the time there. And if some customer also have taken the back their what do you say booking, they've taken right, then based on his name that ticket is going to be booked now, so it is also for the loss. So as they are not distributed separately, these were the challenges they were facing with. So some more examples for this we can see there in this as inventory control, traveling waiting list, stock market. Inventory control means what? We are maintaining the records of some stocks, right? Like it can be a business, any business for that which is having a stock market. We are maintaining for stock market. What we need to do for a minute to minute, we need to maintain, right? As well for traveling details also. So for these all three kinds which have displayed on your screen, we need to maintain minute to minute information, and we are supposed to maintain some set of rules. Means at this time, if some suddenly the stock has been reduced, what to do next? Those automatically rules has to be executed, but those all things were not there in your traditional database. So next to that all has the drawbacks made active database to come into existence. What do you mean by active database? Active database supports the preceding application by moving reactive behavior from the application into the DBMS. Means it's not going to divide into further separate applications, but whatever the application is there, it's going to define in within the DBMS implicitly. Our commands also, as well as the rules associated with that commands also is going to be executed within the DBMS, that is database management system. So what is active database are able to monitor and react to specific circumstances of relevance to an application. So what it's saying, if an application is executed, so our active data is going to be monitored and it's also going to react to that circumstances. Okay. what a model has to provide an execution model, means a runtime strategy, how this model is going to work. We'll see the general idea for this active database. Means it provides a regular DBS primitives plus a definition of that applications and triggering of applications. Means application means if we are in the database, we are storing a train, okay, for railway support. So railway defines some application, means booking of tickets, okay, reservations will be there, cancellation will be there. For all, we maintain some application within the database. So that in active database, we are not maintaining only that, but including to that, we are maintaining some triggers which are associated with that application also. So what does it mean? It means that it's going to be react automatically to the situation in the database. Means it's not waiting for the external client to do something. If something happens now, what action has to be taken? It won't wait for the external client. It automatically triggers, it automatically invokes that trigger set of rules and it executes that. So allowing the specification and implementation of the reactive behavior, means smoothly we are going to execute our application. Now what are the DBMS? Embedded situation action rule in the database, support many functionalities like integrated control, derived data, change notifications. Means we are going to define some constraints on that. Okay, integrity control means constraints, so that we can define the data with some set of rules, right? And the active database is going to it came into existence from SQL 1999 as triggers has came. So we were using the triggers in SQL from 1999 version onwards. Your active database model. The example of your active data model you can see on your screen, which is recognizing predefined situation in the database. Means we are defining some set of rules like triggers, and what we are saying, what are the actions also we need to take when that situations occurs. So active rules, rules that automatically triggered by the events in the database. So you can see here active DBMS maintaining some records. Okay, so what it's saying, these 25 copies already sold. Here in the last diagram, we have seen here we were having a stock updates, means external clients is being maintained as stock updates here. But that stock updates we are already maintaining within the record with the help of triggers now. So you can see on the down on update of sales, that is when quantity is less than 5, it automatically what it does, it orders the 100 copies. So previous what we have seen, okay, stock we are maintaining by the other client and other was doing by from other clients. So that was not automatic, but with the help of these active databases, as we are defining some set of rules on the records, so it is automatically smoothly we can function our business here. Okay. ECM model, that means event, condition and action model. Like we have seen about event, condition, action in the triggers. The same thing we'll see it now here in terms of a model now. Most active databases support a knowledge model that uses rules with 3 components, that is event, condition and action. Most of the databases using this model. The event part, what it is going to be described is going to be describes a happening, a situation. It's going to be defined when the rule may be able to respond. Means it's describing at what time the rule has to be respond. And condition, it examines the context in which the event has to be take place. Right. So this already we have seen it. Event means some set of codes which is going to be happen when the external user is going to give a command. And condition, we are going to check the condition to do some actions. Based on the condition only, the action is going to be performed, right? So the condition is going to be checked here with the help of the triggers, and action also is going to be taking care with triggers only, which describe means what actions we are going to be taking. Okay, event. So at what possible alternatives or what at what function this event is going to be invoked, we'll see. So these all are the operations on which event can happen. Structure operations, like if we are using insert, update, and access commands, then the event is going to be invoked. Behavior enforced. If we are going to display some messages, means the user is saying ki just simply display a message with some command like set command or set message command. On that also events going to be occur. Transaction, abort or commit or begin transaction. If you're maintaining any transaction, like for example, ATM transaction, right? We can do ATM transaction by putting our ATM card, okay, in our ATM machine. If we fail to give a correct pin, what happens? It abort the transaction, right? So what automatically it's going to take an action, right? So that on that case also events going to happen. Exceptions, conditions also, clock, action. These are all the functions which makes events to happen. The conditions indicates that where the rule action should be executed. Means it checks for the condition to execute the action, the action to be performed. So it checks the condition first. Once the trigger event has occurred, means event already happened, then condition is going to be checked. And if it is true, then the action is going to be executed. How action can be performed? The range of the task, means in the action we'll define some set of tasks. Yesterday's class we have seen for after the update, after delete, we have defined key if it is performing after update and delete function, capture those data and copy into some other table. So those set of actions is going to be taken at that time, right? So similarly, what it does, it executes some sequence of SQL statements and perform some behavior invocation within the database or external call also. It is not only that it is going to be executed within the database also, but it can take some external calls also. Means it can take the data and can write into some other database also. As I have said here, we can define triggers not only to the database, for whole SQL server also we can give a triggers. Okay, inform the user or system administrator of some situations. Means action, these are the actions that can be happen. Some examples are given here. Okay, it's going to be informed to user or system administrator of some situation. Means if not a genuine user has been access the database, then we should not provide an access to the database now. So obviously that has to be about the transaction, as well as we need to send some message to system administrator also. And aborting a transaction, ATM, we can take the example. If is not putting a correct pin, then transaction has to be aborted. Some alternatives also we need to take sometimes, right? Some alternatives. So these are the things action is going to be performed. The execution model for our active databases. This is your execution model, means how your event is going to be executed step by step is showing here. Okay. So from event source, the event is going to be happen, event going to occur, then trigger is going to be happen, evaluated and selected rules. How? We'll see one by one. The first is signaling phase, means it is a event source from where events is going to be happen. Okay. Next is triggering phase. What the triggering phase does, it again check for the three conditions, three parts again is going to be divided, that is event, condition and action. So triggers are corresponding to rules. The evaluation phase evaluates the condition of the triggers. First event has been raised. Next, in the evaluation phase, the condition of the triggers is going to be checked. Next, in the scheduling phase, indicates the rule conflict set is processed. Means what are the set of the rules? If condition is matched, what are the set of the rules we need to execute? Those are processed here. And the execution phase, what it does, that after after checking the condition, what the action needs to be taken, that action is going to be executed in the execution phase. This is what about your event execution. some designing and implementation issues of the database we'll see. So active database allow users to make some following changes to the should allow means it has to allow, that is to activate, deactivate and drop the triggers set of rules. Means if some default some triggers has been defined, but we need to add some extra data. Okay, so as the already triggers are active, we are also sometimes not able to add the data to that particular database. So the user should have to allow these kinds of some changes to be made to the triggers, that is activate, deactivate and drop. Yesterday we have seen how to drop a trigger, right? So the deactivated rule is not be triggered by the event, means it's not going to be function here, but we can use this feature by selecting some deactivating some particular rules, not the triggers. Means on particular table we'll set some set of rules, for second table we'll define some set of rules. So if we deactivate the trigger, what happens, both the tables are not going to be have those certain rules, right? But we want for only a particular table. So the best practice is to just to deactivate some certain kinds of rules for some period of time, not for every time. Okay, the activate command. So activate command means we are again reactivating. How we can reactivate the trigger? With the help of alter command. Same as that alter table, here also we are having a alter command to activate the trigger. Drop command. Drop commands yesterday also we have seen. Yesterday we have seen how to drop means how to delete the trigger from the database by using a drop command. Okay, some more issues we'll see. The second issue, trigger action should be executed before event is whether the action should be taken before or after. Means we are defining a trigger based on before and after now. So this is the implicit issues of a Dbms which is happening here. So that event can be considered in three ways: immediate consideration, deferred consideration, detached consideration. What has those we'll see. It is a part of the same traction and can be one of the following depending on the situation. Means immediate consideration. So whatever the triggers are there, it is a part of the same transaction. In the same transaction only we are defining those triggers. So this immediate consideration is an example of your Oracle model in which we were having a triggers as of before, after and instead of also there. Okay. In MySQL, we are saying only before and after. In Oracle, we were having before, after, and instead of. So in immediate consideration, what happens is we are using a set of rules within the transaction itself. Deferred conditions is evaluated at the end of the transaction. Means first and transaction is going to be happen. Means if we are using a insert or update, first of all the insert or update is going to be happen. Then the set of rules are going to be executed. Detached consideration. Consideration is evaluated in a separate transaction. This set of detached consideration is happen in your SQL server, in which we are writing a separate code for the trigger, separate codes for the commands in separate transactions. Now, some of the active database applications you can see on your screen, right? PCA rules have been using to support the integrity constraints, means to define some set of rules. We were using this in materialized views. In views also, this is going to be applied. Maintenance of derived data, coordination of distributed computation, transaction models. So these are the some of the applications in which active database is going to be used. Okay.